here we go. We're going to be doing angle relationships with tangents, chords, and secants. And I want to point this out. It's really significant that these are angle relationships, not lengths of segments. We're doing their angles. This is the 4th section of the 9th unit. All right, here's a drawing that you have seen on your Formula Madnesses. And we have 2 items. What is this one here? It's the bottom one that's just touching once. What is that called? A tangent. And then the one that goes from AC down, what is that one?
Chord.
A chord. All right, good job. So we have a chord and a tangent. You have also in your postulates and theorems inside your postulate book or just in your term sheets, you have a theorem that tells us what happens here. If you have an intersecting tangent and a chord, what is the measure of the angle of the intersected arc? Well, here's the first one. I'm going to tell you that angle 2, this angle, let me just get yellow here. If this angle here has a measure of half this intercepted arc, half, we have to give 3 of them since it's a major arc, 1, A, B, and C. So, what is the measure of angle 1 going to be?
Half of AC?
Half of this intercepted arc. That is correct. Half of this intercepted arc. Because angle 1's right here. This was on your Formula Madness. This is another reason why you having your Formula Madness is already done is going to help you not only for your final exam, but for doing your homework now. Okay? So measure of angle 1 is going to be half the intercepted arc. This is on your Formula Madness already. If you do want to write it down, you can, but it's on your Formula Madness already. And I'm just reiterating the fact that it's on your Formula Madness. All right, now we have some lines, and we're going to draw some lines. I want us to explore the ways that lines can intersect a circle. I have one of them right here. I want them to intersect on the circle. I want them to intersect inside the circle, and I want them to intersect outside the circle. All right, so how can 2 lines intersect on this circle?
Tangents that are on the same point, I guess.
2 tangents, let's see. Are they going to intersect? They're intersecting on, though. Are they going to be... So you want me to... They're going to intersect on the circle. So you want me to be here. That's a tangent. How can I... You said tangent. So how can I make it intersect on that circle?
You can't because they'd be in the same line. The same thing.
2 chords?
2 chords, maybe. Okay, so if I drove all the way through, just this little piece of one over here will be a chord. Mm-hmm. So how will it intersect on the circle? Where is the circle? Is the circle this green part, or is it the black part that's on the edge?
The black part.
It's the black part on the edge, right? Okay, so if I'm intersecting this on the circle, is that intersecting on the circle?
No.
No. How can I make it intersect on the circle?
You make another line that's kind of like really tiny that intersect. I can't even speak now. It's the same point as the dot at the top there.
The dot at the top. Is this the dot at the top you're referring to somewhere up there?
Yes.
Okay, so you want me to intersect it somewhere like one back. Like that would intersect there, right? That would intersect on.
Yeah.
I could maybe even make it a tangent to intersect on, right? Mm-hmm. And it's intersecting the circle. So I could go like that also. We have talked about if I just come in here and I erase some of this. This, you talked about a minute ago, a chord, I heard. And if I stopped there, we already have a measurement for this angle. We've done it before, right? Mm-hmm. Okay. We just talked about what we could do if we did, just a second, this one right here. We just gave you, if that was a line, a tangent, and a secant. How could let's do the next one now. How could I intersect inside the circle? That was on.
Like you do there, it comes on the inside.
Okay, so I just go like that and then like that. Is that inside the circle?
Mm-hmm.
All right. Those could be 2 secants. It also could be 2 chords. Can it be a tangent?
No.
It cannot be. This one cannot be a tangent. The top one, this one up here, could be a tangent. Not 2 tangents, a tangent and something else. But this definitely cannot be 2 tangents. What about outside the circle? How could we intersect outside?
One up and one that way.
Yeah.
Tangent, secants, what?
2 tangents.
2 tangents? I could do 2 tangents.
One going up.
So I got one coming like that and one coming like that. There's two tangents. We have experienced that already with at least the lengths of these links being equal, right? Is there only two tangents? Is that the only way it could be outside?
Two chords that extend, I guess.
Two chords that extend. They won't be chords if they extend. What would they be called if they extend? Two secants. So I could go up. Oh, yeah. We have those two. I'm going to make it a little more drastic. I'm going to go like two secants. Do I have to have two secants? Can I have something else? A secant and a tangent. So here's a secant. Let's do a tangent. There we go. A secant and a tangent. All right, there we go. Lots of different ways they can intersect. We're going to explore all of those, finding their angles. All right, we draw on with no... Oh, we drew this one. We did some tangents. Here we go. We're going to draw some right here. Are these two secants, two chords, a secant and a tangent? What are these? Two chords, all right? Two chords, and we're doing their angle measures, not their lengths for this unit during this lesson. If you have two intersecting chords, what is the measure of their angles? This is our one of our formula madness. I want you to notice that we are adding, and we have angle 1 is right here. Angle 1 has this arc, and by the way, vertical angles makes that angle 1, and this intercepted arc. We add those intercepted arcs. We have CD right here. It goes with that one. And we have AB, which goes with this one. All right, so now if we want to do angle 2. How do we do angle 2? Angle 2 goes with two pieces. It goes with these two.
CA and DB.
CA, I agree with CA. And DB, what are we going to do with those? I already have the adding. What else do I need to add? Put 1/2. That's correct. These are on your Formula Madness, by the way. On your Formula Madness. I want to give you something to help you remember this. These things intersect on the inside. If they intersect on the inside, you're going to add to find their angle measures. In a moment, we're going to have some intersecting on the outside. You're not going to add, you're going to subtract. Okay? All right. I want to reiterate that this is on your Formula Madness. All right, now, we're going to do the same thing we did, except we're going to have only one tangent, two tangents, and no tangents. I want to know how we can get these to intersect with one tangent.
A tangent and a secant.
Tangent and secant. So I have a secant and a tangent. There we go. I might have needed to come a little bit more. Nope. There we go. There we go. Secant and a tangent. Two tangents.
They already intersect, right?
Are they going to intersect outside or inside?
Outside.
Outside. All right. Two tangents. We've done this one a little bit ago. Two tangents here and... I maybe should have made this one a little longer. Two tangents. All right. What about no tangents? Can we have no tangents that intersect?
Chord and a secant.
A chord and a secant. So are they going to intersect on the inside or the outside?
Inside.
Always? A chord has to, doesn't it?
Has to.
Inside or on.
So we have that one.
Yeah, inside or on. That's
On. Oh, it could be on. It could be on? If I do it on, it's got to be like that, doesn't it? Right? What if I have two secants? Two secants. Can they... Oh, my bad. I want to get that back.
Out. Yeah, it could be both.
So the two
Depending on the
secants can be inside or outside?
Mm-hmm.
So I can do this where it's inside, and I can do that where it's outside, right?
Mm-hmm.
All right. No check. So I can, and I think we explored this on that last slide also. All right. Here we go. We drew our waves, and this time, we want to make sure they're outside. How can we get we did every single one of them, but one tangent, and they intersect outside. Can I do it? Is it possible? Here's a tangent. Can I make something that's only one tangent?
Yes.
Is it going to be a chord?
No, a secant.
Has to be a secant. All right. We have an arc. We're going to explore this angle right here. two tangents, and they have to intersect. We already did that one, and automatically was outside. We couldn't get a tangent on the inside. But no tangents, and it has to be on the outside. Two secants. And we did that one already, didn't we? All right. Okay. That's exactly what we're going to have here. We have intersecting tangent and a secant, two intersecting tangents, or two intersecting secants. What are the measures of the angles? I'm going to just bring up this one. Is this secant tangent, tangent tangent, secant secant? What is that?
Tangent.
Secant tangent. We are going to try to find this angle right here. I told you a hint about if it's on the outside, what are we going to do with those arcs? Subtract them. So, we're going to subtract them. What do you think that it's going to be? Measure of angle 1. A half. We're going to have our intercepted arc, which in this case is C what?
CB minus A.
Yeah, CB minus AB. Before we go too far, why? Does it have to be CB first, or can I switch them around?
It has to be CB first because it's bigger, so we want a positive number.
Yes. CB has to be first because it's the larger of those arcs. Notice how small AB is over here. It's small. I have to take the large one as the small one, otherwise I'll get a negative number. You can't have a negative size arc, at least, angle, at least not right now that we're talking about it. Later in trigonometry it means something different, but right now we're doing positive angles, all right? Let's look at the two tangents. Two tangents, I have another dot here. We're going to do, I'm going to take out this thing because I have too much stuff going on. We're going to have the measure of angle 2. It has a 1/2. That's a recurring theme. What plus or minus what? Which one's the bigger arc?
EFD.
EFD.
Minus ED.
Notice I have to have 3 when it's a major arc. I have EFD, and minus ED. Scoot this over so I have room. Minus ED. Is that what you said, ED? Yes.
Mm-hmm.
All right. That was is this a secant, tangent, tangent? What was that? Tangent. Here we go. Last one. What are those two things? Two secants. The formula is almost... the concept behind it is very much the same. So I'm finding the measure of angle 3. I'm going to do the 1/2. I'm going to do open parentheses besides Heidi and Naraya. What am I going to subtract? Help me out.
J like G minus JG.
I heard J what?
IG or JHG, whichever.
Let me just, I'm going to highlight this right here. Intersects the circle at 2 arcs. This arc right here. And I don't know if I like that color.
Oh, yeah. Wait.
Let's do like red. This arc here and that arc here. So what minus what? Which one's the large one? HI or JG? HI.
So when it's inside and you have the 2 arcs like that, you don't have to worry about giving like the 3 number thing?
That's correct.
Okay.
All right. HI minus JG. And I'll make my G look like a G instead of a 6. We had troubles with that earlier, right? And I'm going to close my parentheses. You just can't see it there. Questions?
You're gonna put your arc.
Oh, did I not put an arc over it?
JG.
Oh, no. Thank you, Amy. There we go.
It's not a question.
It's not a question. It's just a detail that we need to make sure we remember. All right. I've given you that again. We have half. We're subtracting the arcs. Make sure you get the larger one first. We're subtracting. This one I want to reiterate. I want to talk about this one, though. We're going to stop. This whole thing. This is the only one of the 3 where the whole circle is being represented. This one, I have this half and this half. If I add up EFD and ED, what will be the degree?
360.
360. On these type of problems, they don't have to give you the full dimensions. If they told you that this one was 60 degrees right here, you would know that the blue part was 300 because you could subtract from 360. On the other two, they have to give you the two arcs, but this middle one with the tangent, they only have to give you one because you can subtract from 360 to get the other one. And the last one, we're still subtracting. They're intersecting on the outside. It's the larger arc minus the smaller arc. All right. Again, those are on your Formula Madness. We found her fib. Now you're going to find the fib in here. This is a geometry fib. You are going to get my personal fibs eventually. My personal fibs. Now, so I want you to look at this, and I want you to decide if A, B, or C are the wrong one or the fib. I'm going to give you a couple seconds to look at it. How many think they know which one is the incorrect one? A, B, or C? Give me a hands up when you've made that decision. How many think it's A? How many think it's B? How many think it's C? All right, so you guys think B is the fib?
Yeah.
B is the fib. Angle B, when you have a tangent and a secant, we subtract nothing.
Yeah.
We just do, angle 1 is half of this. How did they get the 210 though?
Because
I
they
did.
subtracted 150 from, or
Yeah, 150.
Yes, and a moment ago
I
I
did that
said
just
something that was actually a fib, and I didn't mean to. I said that middle one was the only one where they added up to 360, but one of these also does. This distance here, this distance right here, plus this around here will add to 360, so it's also not complementary. What do you call it when it's 360? I don't remember. But double supplementary. So that's where they got the 210. Okay. All right, let's do another one.
No, well, thank you.
All right. All right, it's time for you to find your geometry guess-the-fib. Here is your diagram. I want you to decide if A, B, or C is the fib, meaning the one that is incorrect.
Yeah.
Okay, so how many think it's A that's the fib? How many think it's B that's the fib? That leaves C that's the fib, right? Because that's what everybody guessed. Okay, so you think C is the fib. You are correct. C was the fib. All right, before we go too far, we have almost all the information about this circle. We know this is 40. We know this is 50. We know this is 120. That's 90 plus 120 is like 210, right? So what's left over for this?
150?
How much? 150? All right, so that's 150.
Yeah, I did it on my calculator.
And so that would mean that y is half. And why are we adding again?
Because they're inside.
Because they're inside. So this being subtracted would actually give you some indication that it might not. And 180 doesn't even fit anywhere in there. So definitely,
I thought it was subtraction, that's why I said.
that's why you thought so. Okay, that's good. All right, here we go. All right, now we're going to do our geometry guess the fib. Here's your diagram. And which one of these is the fib?
I think I know.
I've got one person who knows, two people who know. By the way, the fib was B and D. It wasn't a 25% chance. There's two of them that are wrong.
I thought it was C.
I thought it was B.
I thought it
So
was
C is
Oh,
correct.
I thought it was
C is
B.
correct. So, okay, this intersects outside the circle. So which one of these couldn't be it?
Oh, we're
D can't be it, right? So D is wrong.
Yeah.
The fib was because it's a add, right?
Oh.
Then why is it not B though?
That's the one I thought was right.
Well, because whenever we're doing this, it's the angle equals the two subtracted arcs, not the arc. Okay, so it's always the
Yeah.
angle.
So if we were
equaling
looking at the
these
angle instead of where
subtracted.
the X was, then that would
Yeah, got it.
yeah.
Yeah.
I
Okay.
did the same thing as you.
All right.
Oopsie.
And if you would have solved A, you would have gotten 48. All right. Here's our, I think, last, at least close to last. Geometry guess the fib. A, B, or C. Which one is the fib?
That 170, is that an arc?
That 170 is right. Yes, it's an arc, but it's only this piece of the arc.
Okay.
Okay. Any other questions? There's something that intersects on the inside and on the kind of like outside or on this time. Okay, so I've got how many people who know? 1, 2.
I'm not gonna say I know.
Okay, you believe you picked. Okay, how many think A is the fib?
Wait.
B is the fib? C is the fib? We don't know. All right, here we go. A
Yes.
was
Okay.
the fib. All right, so A was the fib because instead of adding, you were supposed to be, it's just subtracting, you're supposed to add. That meant this one was good. But where in the world did they get the 160? I don't see one that says angle. Okay, so let me draw something up here. This angle for angle Y goes with that whole thing. That means you have to have this edge. And if you add the 78, the 130, and the 170, and subtract from 360, this part will be, I don't know.
Do you want me to get my calculator out?
Yeah. Or you could just do, actually, wait, that's not too bad. I don't have to do it that way. You could do it this way. The 30 and the 70 is 200. So this whole thing has to be 160. That whole thing there.
Wait.
Yeah. 30 and 70 is 30 and 170 is 200.
Yeah, so
then
this part here
it has to be
not
160.
yellow. This part right here is 200, right?
Yeah.
So what's left over at 360 minus 200 is 160. So that's this whole piece. And that's how they got that 160 right there.
Yeah.
Okay.
Oh,
So that one is true. All
I
right.
checked. I noticed that C was the same, and then
All right. Go ahead. Let's get out your
Too much.
homework. So what am I going to add, subtract, multiply, and divide on this one? If this one right here, if this whole thing here is 290, what's the leftover piece?
80, no, 70?
Subtract it from 360.
90. Oh, yeah, 70. Sorry.
70. Okay. So then angle LKJ is 1/2 what?
1/2 7?
Yes, 1/2 of 70, which is what?
35.
35.
Very good. 35 degrees. Let's check it just to make sure we're right.
Okay.
I can't. Anyway, that's fine. All right, number 3.
I'll
Number
come
3,
back. Okay.
very much like the other one.
Sometime this week.
Maybe in the morning.
We're looking for this angle right here, and that angle right there is 6x plus 10. This arc is 21x plus 10. How much is the yellow arc that I'm drawing right now?
Well, we have to figure that out, right?
Yes.
By subtraction.
Subtracting from what?
21x plus 10.
Well, this angle measure is the 6x plus 10.
So 360 minus 2x.
Yes, this yellow part is 360 minus 221x plus 10. How does that help us find that the 6x
Oh, they're equal to each other.
plus 10 is equal to what?
1/2 of.
A half of that 360 minus. Be careful with that minus, though. I did not do that very well. I should have done this, minus with the parentheses. Be very careful because it's minus the whole thing. And so for those math people who need to have brackets and parentheses, I don't mind having parentheses and parentheses, but some people like brackets.
what?
21x plus 10.
Oh. Okay then.
Okay. I'm going to give you a couple minutes to work on that. Be very careful as we're going along. I'm going to work slowly up here. You look up every once in a while to check yourself. What part are you confused about, Mariah?
How are we gonna just? Oh wait.
This is what I did. I distributed this negative into
Wait.
those.
Oh yeah.
Okay.
That clarifies.
And then I will then combine the like terms.
So I'm gonna do half first, right?
You could, or you can actually do the reciprocal and double these over here if you want. I don't like the half, but maybe actually it's probably going to be okay because no, that 21 is going to be ugly half. You know what? This half that's over here,
I'm sure
this
Mariah
half
would
over
have
here. If I distribute this half, I'm going to have a fraction with that 21. And personally, I don't want a
That kills
fraction.
me.
So I'm going to multiply by 2 over 1 on both sides. Then I won't have a fraction. Is that okay?
Yeah.
So I'll have 12x plus 20 over here and 350 minus 21x. I like that better because then I don't have a fraction. You can do it the other way. It's not going to hurt.
Wait a second.
So I'm going to have 32x equals 330. Is that right? Did I do that? Is it really 32x equals 330?
Yeah.
Okay, is it going evenly?
Wait, 32? I got 30.
3. It's 33. That's what. Okay, yes, it is a
Where did I
3.
get 33 from?
Okay, so I moved this 21 right here, and I added it to the 12. That's where I got it, right
That's
here.
how I got it too.
And it turns into 33.
I did the decimal. I just used all.
Huh?
Which did you did the 21 over
When-
2 as a decimal?
Yeah.
And what'd you get as 22 over 2?
Like when I did the whole
21
thing.
over 2 is what decimal?
21 over 2 is 10.5.
Right. And then you should have done
So then I added it
over to the other
6,
side. Yes. So it'll be
Oh, yeah.
6 and
16.5.
okay, 16.5. And then
Subtracted the 10
Uh-huh.
from 180
Mhm.
to get 170.
yep, that'll be fine.
And
You'll
then-
still when you divide, you'll
I
still you get what?
I
X
divided
equals
those and got 10.30.
Yes. Should be even 10.
Should be an even 10. That's what I got.
Okay, so let me just see. You didn't use over here. You said it was 6x plus 10 equals what's half of 350?
I hope I did
350
this
is
right.
180.
Yeah.
Wait, 350. Oh, half of 350, not 360.
Yeah. So there's maybe where what happened, Brett. It's not when.
Oh.
Does that make sense? 11 over
Okay.
2, which
Answer
is
10.
Yes,
Got
that's
it.
what I got.
Okay, I don't know what you're talking about, but I did it my
Okay.
way. So
It's 170.
as long as I
yes. Then you'll get. Then it should still divide out to be 10. Okay. Yeah. If you follow the rules of algebra correctly, even though we did it in a different order, a different manner, we should get the same answer. Okay. All right. We're gonna now move to number 5. And if I come over to here, I should get x equals 10. That's correct. All right, here we go. Let's do number 5. All right, what are we going to do to find angle M is the question mark there. I'm going to call it x, personally, like that. What are we going to do to find angle x?
Wait, are you calling the question mark X?
Yes, I'm calling the question mark x. X equals, the measure of angle x equals, it's been half.
152 plus 80.
We're adding? Or are we
Yes.
subtracting? You sure?
Yes.
152 plus 80, I heard. Do we agree? Okay, so then what is 152 plus 80?
232.
232.
Boy, couldn't you just type the whole thing in your calculator?
You can type the whole thing in your calculator with the parentheses and all. One fell swoop, be done. 115. 116?
Yep.
All right. Number 7. Yep. Okay, 7. All right, now we have a big long equation. What equals what?
49x plus 2
Plus 2 or minus 2?
minus 2
Okay.
equals
Half, is it something plus something or something minus something?
Plus.
Plus, so we can
don't
just,
have to do parentheses.
so we don't have to do
Inside.
except, and on in the inside. So we can just do 66 x plus 3. We can just add it to the 27 x plus 3, right? All right, so I again I want to take that 1/2 and move it to the other side and double it. I think it'll be nicer than not having that fraction. So I think 49 doubled is 198. No, just 98. 98x minus 4. And 66 and 27 is 3. 93?
Can we
Yeah.
simplify first before we do the 1/2?
Yes, definitely. When I simplified, I got what's up there. Oh, and I don't forget this x right there.
And you just did the switch the 1/2 thing over again.
Yes, I just moved the 2, or doubled the other side instead of distributing that half.
Yeah.
I think it was actually easier that way.
Probably would be.
Oh, I wouldn't get a fraction.
You know how many years I've tried to be, and it's never gonna.
You know, you haven't gotten even close to half your life.
I
So,
know.
So you have time to still gain some love.
I
for-
can do it, but I don't think I'm ever gonna.
I got 2.
I did too, but I have a question on the next
Yeah, I
one.
got 2.
All right.
Wait, what?
Shh, don't stress, Amy. Just keep
Don't-
working.
I'm here.
Oh, that's okay. So you just this.
Did I do stuff right? Did I do it right?
I don't know.
Can you check?
Then just divide by that, and x equals this. No problem.
Okay.
All right, let's go on.
No, wait.
No? Okay, I'll wait.
2.
What did you get for 8?
For 8?
Why am I so
I didn't do it
slow?
yet.
Oh,
Did you do 6?
Wait, what?
No.
What did you get?
Okay, just okay.
83.
I'm honestly just going to tell you I'm going to do that.
All right, Amy, how you doing?
Almost done, sort of, maybe.
Okay.
Possibly.
Hey, don't stress.
I'm going over to number 9, just getting it started.
Just like what you're.
All right, number 9. Are we going to subtract some numbers or add some numbers?
Subtract.
Subtract. Number 9, we're going to go the measure of angle L equals 1/2. We always have that little half in there from what we've been doing so far. What, and you said subtract, what minus what?
204
Uh-huh.
minus 86.
Good job. 204 minus 86. And we don't need to do any doubling on this one since it's not really, it's an equation, but it's all on one side. So we just need to do the 204 minus 86. Someone help me with that.
118.
I heard 59. Is that correct?
Yes, ma'am.
All right, are we ready? Amy, what did you get for number 9? Anybody get?
59.
Yeah, 59. Okay, so we're ready to move on to number 11. Is that correct?
Yes, ma'am.
All right, here we go. Number 11 is the same concept. It's just now with an equation. So we have 6x minus 1 equals 1/2 of what?
139 minus 69.
139 minus or plus?
Minus.
Well, how do we know it's minus?
Because they're outside.
Because they intersect on the outside. Okay. I think that's going to be 70 on that side. Okay.
Can't wait to go back to
And I really want to do what I've been doing. I don't want to half 70 because it'll be a fraction.
Nope. Well,
Oh, no, won't it be 35, won't it? Okay, so it'll be 35.
Can I just do that?
I did the
part
other
in,
way.
like,
You want to double it?
I did that, yeah.
Okay, you can do the double. If your rules of algebra are the same, we should be fine.
I'm just gonna put the whole thing in my calculator on that one side. It's just,
Oh, no wonder. I was like, something's wrong. It's going to be a fraction. They usually don't give us fractions. So I'm going to move that over there.
wrong problem.
So 6x equals 36.
I got the same answer that you're going to get.
Okay.
I got 6.
That's what
I got 6
and-
also. All right, here we go. Let's go to number 13. All right, this one, they only gave us the 240. Oh, no. What-
Don't say that.
What's
you
the
know,
other
my brain
part?
hurts.
360
X.
minus.
It's
Yes. What is 360 minus 240?
120.
Very good. So angle T, or question mark is what we're looking for, is 1/2. Is we going to subtract those two or add them?
Subtract.
Which one am I going to subtract from which one?
2.
The
40.
240
big
first.
one from the small one.
The big one minus the small one. We're taking the small one from the big one, but yes.
Is it always just by the numbers, or will it sometimes make you do the negative?
No, you're going to always take the bigger one minus the smaller one.
The bigger number.
In this kind of a problem, with this arc, you're going to take this big arc minus the small arc.
So now you know what 1/3 of 360 is, I guess.
So it's just
What?
60.
60?
Yeah, that's what I got.
That's what I got.
Subtracted that just to find out it was 120 again.
I know, and then you look at it going, wait a second. Oh, I understand. You put in your calculator, it looks like that it just regurgitated back what you put in, and
Yeah.
it didn't really. All right.
Oh, you guys are doing it the long way. I'm just typing the whole thing in my
Yeah.
calculator.
Yeah.
Yeah.
I'm doing it a long way.
You could have just, once you get this, you could just say 1/2 open parentheses 240 minus 120 close parentheses and be done.
Yeah.
On the same problem or a different one?
No, a different problem.
Okay, well, I'll help you later.
No!
All right, here we go. We're going to do number, I said 1 through 13 and 16, correct?
Yes.
So we're going to do 16 now.
Oh, wait, I think.
Yeah, I'm pretty sure.
Oh, I think it just said 1
All right.
I thought you just said 1 through 13.
And then 16.
Oh.
All right, so what in the...
yeah,
How do I do this one?
16. You use math.
7.
We do. How are we going to know what this little piece right here is?
Just put it on the same side. Wouldn't be 360 minus that?
This is
Wouldn't
360.
it be-
Oh.
Oh.
What? What were you
That little
saying?
purple part's 360
Wait. did we,
minus...
skip 15?
What?
2x.
That one purple part is
20x.
what?
26x.
360 minus.
That
Plus.
one?
This purple
Oh,
part right
okay.
here is this down here. I'm actually going to do this so it can fit in there a little better. I'm going to put
How
it
is
in.
that one purple part 360 when the whole circle?
No.
Oh, it's 360 minus 2.
Ah, got it.
Yeah. Except it's no. Okay, you guys can see it pretty good.
Right.
All right.
Ah.
All right. So, how are we going to write an equation for this?
7x plus 16
Equals 1/2. Are we subtracting some stuff? Are we subtracting these two? Or are we adding the two? Subtracting. Which one? What are we writing first? Are we writing the 26x plus 25 or the 360 minus all that stuff?
The 26x plus 20.
Yes, the 26x plus 25. Be really careful. I'm going to subtract a bunch of stuff and I'm going to make it a different color parentheses so that
Wait, is that
you can't see that
1B
parentheses.
Or LP?
That's 16.
Okay.
And then we're going to do
It
360
looks like a V.
minus. Can I do this? I want to do something. I want to do this, you guys. I want to actually distribute that minus as we go. So that will be 360 minus 26x minus 25.
Okay.
All right, when I stick it over there.
I'm just gonna set it up and solve it that way.
Okay.
Wait, where are you? Never mind.
Got it, Amy?
Never mind.
Ask me questions.
I figured it out.
Please ask me questions.
I
Please.
figured it out. I was asking why you're putting the 360 thing in there, but I figured it out. That's why I was like.
All right, so now,
Now they're all going to be positive again except for the 360.
yes.
Why
So I'm going to just work on this side. 1/2. I'm going to distribute that negative to everything. And we'll have 26x plus 25 minus 360 plus 26x plus, it's falling
Okay,
off.
wait. So we just put the whole -1 thing into the 360, the 26x, the 25 thing, or are we just gonna like? Never mind. Yeah, I know.
I'm going to
I don't
combine
know
like, this is what I'm doing right now, Amy. I'm combining like terms. If you could do that in less steps, that's fine. I'm going to put those two together. I'm going to put those two, they're going to cancel out, by the way. One's a, oh, I'm wrong. This is
Wait.
a positive 25. So those are going to come together. They won't cancel, my bad.
Okay.
They'll double.
Wait. So couldn't you literally just? Oh no, you have to make a positive.
Right.
Never mind. I got
Okay.
it.
All right. So I'm going to also, because I'm afraid I'm going to have some negatives, I'm going to take that half and double it over there. So I'm going to have 14x plus 32 equals 26 and 26 is 52x.
Brett, you already have your answer now.
And 25
No,
is, we got
Okay,
50.
I'm
Oh, 50 minus 360 is negative,
310?
yes.
Yes. Yep, that's what I got too, Heidi.
I could have done half of them. It wouldn't have been a fraction, but. All right, so I'm going to move the 14 over here. 52 minus 14. And that over there. So 342. Can somebody help me with the 52 and the 14?
Not there yet, so no.
66.
Yeah.
Oh,
I can't
negative.
help
Yeah.
you 'cause I did the
38?
decimal, so-
I got 9.
That's what I got.
That's what I got.
All right, we've done 3 new theorems. There are from formulas to find, they were formulas to find the angle measures of intersecting tangents, secants, and chords. And these all will be on your Formula Madness. I hope this was helpful. Goodbye.
Okay.